So here's another question from Slay the PE that I grabbed off Reddit. So the question states, a liquid coolant must absorb heat at a rate of 300,000 BTUH in a heat exchanger. The coolant flow rate is fixed at 20 GPM. Option A is to use the water as the coolant, and option B is to use a glycol-based antifreeze. The glycol solution temperature rise across the heat exchanger is most nearly what? Okay, so we're trying to find the delta T of the fluid. So if this fluid was water, we could simply use the equation Q equals 500 GPM delta T, and then solve for this guy. But since we have a glycol solution, this 500 GPM does not apply. So we need to use the other equation. Q equals m dot Cp delta T. Okay. So we know that we want this in terms of GPM because it gives us 20 GPM here. So we can rewrite this to 20 gallons. It's gallons per minute. Well, we want this in terms of hours because this is in BTUH. So we do 60 minutes in 1 hour. And then let's go to PE handbook real quick to get the gallons conversion rate. Yeah, so this is what we want. 1 gallon is 0.134 foot cubed. So 1 gallon is 0.134 foot cubed. And then we have a mass or density of 66 pound mass per foot cubed. So 66 pound mass per foot cubed times specific heat 0.86 BTU per pound mass degrees Fahrenheit. And then we have this multiplied by our delta T, which is in Fahrenheit. So let's start canceling some of these. Gallons, minute, foot cube, pound mass, degrees Fahrenheit. So we're left with BTUH per hour, which is what this Q is. So it's good. So let me put this into the calculator real quick. 20 times 60 times 0.134 times 66 times 0.86 equals, so Q equals 9127 delta T. Well, this Q is just this 300,000 BTUH. So 300,000 divided by 9127. You need to put that in the calculator. And we are left with a delta T of 32.87 degrees Fahrenheit. So if we go to our options, 33 is the closest one. So C is our answer.